The Earth, made of four layers: crust, mantle, outer core, and inner core. Tectonic plates are what the Earth's crust is made up of. They're like big boulders of rock moving against each other, which causes friction. When these big rocks get stuck, pressures build up. When this pressure is eventually released, an earthquake occurs. The Ring of Fire is where 90% of the Earth's earthquakes occur, bringing us to Chile. The 1st of April 2014, 8:46 p.m. local time. An earthquake measuring 8.2 on Richter scale struck Iquique, Chile. Aftershocks and a tsunami soon followed. 6 fatalities, 9 casualties, and 25,000 homes damaged. But earthquakes never kills people. The failure of our constructions do, which is why engineers work to avoid this by taking several factors into consideration.
After the earthquake, this property in Chile was damaged by cuts in the walls of all its levels. The building was brittle since the stonework did not allow relative lateral movement. Therefore, ductility in earthquake-resistant structures is important to absorb seismic energy. By building concentrically and eccentrically braced steel frames and by reinforcing the connection between structural elements, we make the building more stable and resistant. This is what we call an adequate lateral load-resisting system. The vibrations of earthquakes can cause landslides, which damages infrastructure. This can be seen in Chile when Route A16 became inaccessible because of the earthquake. In granule soils, a landslide occurs when the shear force of the earthquake is higher than the friction force that holds the soil back. The landslide's effect depends on a number of factors. For instance, the stability of the slope, as in whether or not the friction angle is higher than the slope angle, and also the looseness of the material. To prevent major landslides, the slope can be made flatter and more compact. Furthermore, ground shaking caused liquefaction which affected the soil. Liquefaction is the process by which low compacted soil temporarily loses strength and acts as a fluid. This process was seen in the Chile Highway Route 5. Like landslides, we can avoid liquefaction by making the soil more compact. Another crucial part of earthquake engineering is transportation and crowd management. This is getting crowds out from closed areas like office buildings, stadiums, and schools to safety in case of an emergency. Engineers have to design evacuation plans that allow people to get to safety quickly. These prevent congestion at exits, which is dangerous and inefficient. To create them, they need to find areas that are close and safe and then design the fastest route to them. During the evacuation, we need to avoid U-turns, prevent the mixing of cars and pedestrians, and ensure the ambulance can reach victims quickly.
Our goal as civil engineers in this challenge is to bring relief to Chile after the earthquake and to improve the built environment to prevent earthquakes from having catastrophic effects, so that we could get our hands on changing the physical world for the betterment of humankind.